next question, let's start to look at it and see what this about. Okay, as always, we can always look into the question itself is saying, what's the vapor pressure of this solution? Okay, so then quickly we should think about what do we know about this topic? Okay, so vapor pressure of solution. Okay, so then you probably can also recall we learned the topic called vapor pressure lowering. Okay, so then look at this wording, lowering. Okay, so then right, it hints it's comparing to something else. Okay, so vapor pressure of a solution, you compare to what? Vapor pressure of the pure solvent by itself is lowered, right? Okay, so then now you understand, okay, I'm solving a question, vapor pressure of a solution. Now it relates to vapor pressure of pure solvent to itself. And then what's this content or which equation we can use to solve this, right? That's the next question. Okay, so next question that will be Rao's law will be able to help us to solve this type of question. Okay, so then for vapor pressure lowering, you probably also right heard of this. We have two situations, right? Okay, so one situation is that you have volatile solute and it has volatile solvent. Okay, and then you also have another situation which is non-volatile solute with volatile solvent. Okay, so two situations. Okay, so volatile plus volatile and non-volatile plus volatile. Then we have solute and solvent combination. Okay, so then that's a situation now. Again, first thing first is vapor pressure of a solution, and then Rao's law is going to help us, and I'll have two situations, and then now the next job is to see this question is about situation A or situation B. Okay, so now let's see how we can figure that out. Okay, so now the other hint where we continuously look into the information from the question, then we got a list over here. Okay, so then what does that mean? We have the vapor pressure just for carbon disulfide, and we also are provided the vapor pressure just for acetonitrile, right? Okay, so then what does that mean? What does that mean, right? Okay, so then if some substance by itself is giving us, right, or contributes large enough vapor pressure, what does that mean? That means itself is volatile, right? Okay, same situation for the other substance in the solution. So then you realize, okay, I actually have what? Volatile plus volatile situation. So I have a volatile solute plus volatile solvent. So then that's my situation. Okay, so then you go, how do I deal with that? Okay, so how to deal with that is you just need to calculate the vapor pressure for the total. You go, what do I mean? Okay, so now I'm going to try to draw it or show you real quick over here. Okay, so they're liquid. Okay, so you have a solution, right? Okay, so both of them are liquid in liquid phase or like this. Right? You can just say, I have this as my solvent. I'm just using color to right help you to understand. I have this is my solute, right? Okay, so then what happens, right? Just say my system is closed system, right? Okay, so then they're gonna right add the surface of this solution of this liquid phase, right? Okay, so then they will be able to overcome the intermolecular force and turn into gas, right? Okay, so now since both of my solvent and solute they're volatile, which means they are able to turn into gas. Right? I'm gonna just say those are the gas, right? And now I have just say that's my solvent, also turn to gas. Now let's think about this. We are calculating vapor pressure, right? Okay, so those ones are able to turn to gas. Those are exerting the vapor pressure for us. So now, if we wanted to calculate what's the vapor pressure, right? Okay, so then what do we need to take? What do we need to calculate as the vapor pressure, right? We have that's why we call this vapor pressure total. You need to calculate the vapor pressure exerted by the solute itself, right? Okay. Also, you need to calculate the vapor pressure exerted by the solvent. Okay, so now we need to do two parts of the calculation, but not a big deal because each one, no matter what, we are following Rao's law anyway. Okay, so now you can calculate vapor pressure exerted by the solute by using the mole fraction of the solute times its pure vapor pressure by itself, right? Okay, so now the other one is the same logic. I'm going to use a different color so now we can solvent. So we're going to do mole fraction of the solvent times the pure vapor pressure solvent by itself. Okay, so now we realize, okay, the job is we need to handle one and handle the other. Okay, so we're going to start with the solute. You go, oh, which one is solute, which one is solvent, right? So then definition, the less mole or the less amount, excuse me, in the solution is what is your solute. The one you have more or majority, that's your solvent. So then you just need to calculate the most of each. Then you do a quick comparison. Then you know, okay, which one is my solute, which one is my solvent. Okay, so now let's do that job. The question giving us the grams of each. Okay, so then you go, oh, that's not bad. Let's do that. Okay, so I'm just going to use a different color because we don't know which is which yet. Right? Okay, so you have 45.68 grams of CS2. Molar mass is given. That's very nice. So can use it to do the calculation, calculate moles. So that's 76.13 grams per mole, giving us 0.600 moles. Then we have 16.42 grams of CH3CN. Molar mass is 41.06 gram per mole. And then this turns out to be 0.4. Okay, so now come to this point, we are able to determine which ones are solute, which ones are solvent by comparing how many, right, which one we have more in moles, right? Okay, so this one have less, so that's our solute, and the other one will be our solvent, the one we have more. Okay, so now we can do the calculation according to Gauss law. I'm gonna take that over, so we're gonna follow this. Okay, so now the next question will be how we're gonna calculate mole fraction. Again, definition, right? How do I calculate mole fraction? We're gonna use moles of whatever your target over here, right? So since we are calculating CS2, we know that, we know that's our solute, that's CH3CN, acetonitrile. So then that's what I'm calculating. Okay, so now if that's the case, how many moles by itself is 0.4, and then you're gonna divide it by the total moles. We'll be adding them up, right? So 0.4 plus 0.6. So that's no mole fraction. Okay, remember mole fraction, you always get a number in between 0 and 1, right? Because it's a fraction, right? Okay, so now you get that value times the pure vapor pressure for acetonitrile by itself. That will be 89.5. Don't forget to pay attention to the units, torr. Okay, so look, mole cancels out. We are calculating the pressure. We get the units as torr, which is the pressure for pressure. That's awesome, right? So now I got 35.8 torr. Okay, so now we're done with that part, the solute. Now we can do for the solvent. It's the same logic as mentioned. We're gonna copy the equation over. Okay, so now everything is about CS2. So this is also something you can label for yourself. So then we can keep track of the info. So 0.6 divided by the total, which is again 0.4 plus 0.6 times by itself vapor pressure. That's 357. Okay, so this turns out to be 214.2. Okay, so now comes to this point again. We did calculate, like, right? Remember the giant, right? We're calculating here both solute and solvent contributing to the vapor pressure for this solution. Okay, so now we're gonna just do the last job, add them up as we know, right? Okay, so we're gonna borrow this equation over too, right? So now we're gonna plug them into and plus the other one, 35.8. So now I get my vapor pressure for this question turns out to be around 250. Of course, we can use scientific notation to figure out what's to matching the options. Okay, so now this is a video about vapor pressure lowering for a solution.